Next thing we're going to work on is being able to factor and then turn around and solve. Whenever you take a test on this unit, you will have problems that the directions will just say factoring, but then usually the very next section will turn around and set up an equation, so you'll see an equal sign, and ask you to find the solutions by factoring. So I wrote down the steps of what you want to think about doing whenever you're doing this. You want to first get it into standard form. What that means is you want all of your terms to be on one side, and you want it to have a 0 on the other side of the equal sign. Some problems are already in standard form, other problems we have to do some work with. Then we want to factor by any of the techniques. So right now we have taking out the GCF, we have FOIL factoring with both x squared or a higher coefficient, we have grouping, we have difference of perfect squares, and then we have our perfect cube formula. So a lot of options. Once we do that, we're going to take each factor, set it equal to 0, and get our answers. And we will have multiple answers for most of these. So the first thing you'll notice is it's already in standard form. It has the 0 on one side, all of the terms are on the left. Next thing you want to look at is, can you take out a greatest common factor? And if you look at these three terms, they do not have a great common factor. And then the last thing, you want to count how many terms. If it has 3 terms like this one, this is a FOIL factor. So I'm going to first write down my parentheses. I know that this is just going to be an x and an x. I know because this sign is negative that one is going to be positive and one is going to be negative. I'm trying to get combinations of 18, so again I have 1 times 18, 2 times 9, 3 times 6. The combination that works here that correctly gives us the middle term is 6 and 3. We want the 6 to be positive and the 3 to be negative because I want to get this middle term. You can do the same checks as we had done in class. You can do the outer and the inner, combine them, make sure you get the right middle term. And now I want to find the answers. So when I'm finding the answers, I want to think of each factor as a separate piece to get an answer. So I want to know what makes x plus 6 equal 0. That will give us one solution. And I want to know what makes x minus 3 equal to 0. Now a lot of times you can do a lot of this in your head. You are just subtracting. So your answers are negative 6. And when I add here, positive 3. So I get 2 solutions, both of which, if you plugged them back in, would make the original equation 0. So you could definitely check your work by plugging back in. The next one, we again check for a greatest common factor. There is not one for this. We again count the terms. There are 3 terms, so we are going to try FOIL factor. This one's a little more complicated FOIL factor because of the first number being a 6. So when I'm starting to come up with combinations, I need to think about the 6 and the 5. I'm going to look at the signs. This is a negative, so that means one will be positive and one will be negative. In order to get 6, it's either 1 times 6 or 2 times 3. In order to get 5, it can only be 1 times 5. But I can't plug it in yet because I'm not sure which one's positive, which one's negative. We want to try different combinations until we get the correct middle term. It may take a while. Looking at this, you're going to end up with a 2x. I think our signs are going to be off. I'm going to change my signs. Erase this a little bit here. We're going to want this to be positive times a positive. So we're going to do 3x times negative 1, and then the 2x times 5. And again, you might not get on the first try. As you can see, I started putting things in and then realized I had my signs off, so I had to go back and fix it. But in the end, you want to see, when I check that middle term, I get 10x. When I check that outer term, I get negative 3x, which does give me the correct term of 7x. So don't try one thing and then just give up if it doesn't work. Try again and again until you find the correct combination of factors that foils to give us the original polynomial. Now I need to finish this off by figuring out what the 2 solutions are. I have 2 factors, so I'm going to have 2 answers. So I will need to figure out when 3x plus 5 equals 0. That's this first parentheses. And I need to figure out when 2x minus 1 equals 0. Subtract 5. So we get 3x equals negative 5. Divide by 3. So one of my answers is negative 5/3. And I'm going to leave it like that. I'm not going to write a decimal. It's easier to work with the fraction. And then I'm going to go over here. I'm going to add 1 and divide both sides by 2. So again, I'm getting 2 answers. The difference between this one and the one before is my answers are not whole numbers. They're not integers. We get fraction answers, which is perfectly acceptable. I've got 3 more. Again, all same directions. We want to factor to solve. You'll notice with these, none of them are in standard form. So these have a little bit more work in the beginning. So if you look at the first one, I want to get everything to one side. So I'm going to get all my terms over here. I'm going to subtract 3x. Make sure you subtract it from the x column. And I'm also going to add 5. And again, make sure you add that to the constant location. So we have 2x squared minus 20x plus 50 equals 0. First thing I do when it comes to factoring is see if they have a greatest common factor, and this one actually does. Everything can be divided by 2, so I'm going to take a 2 out front, leaving me with x squared minus 10x plus 25 equals 0. The 3 terms that I have left, I'm going to try to FOIL factor. So I'm going to break down my parentheses here. What I know about my signs is they're both the same, and they are both minus signs. So it's minus, minus, and I know I have an x and an x. Not a lot of ways to get 25. It's either going to be 1 times 25 or 5 times 5. The combination that works is 5 times 5. It's nice to get in a habit when you notice this is the same factor. We call it a repeating factor. This is another way to write it. And it's a way that's going to help us as we go through this course. Writing it there, it's there twice, so writing it as squared. Either way, you can write it either way, you'd be correct. When you go to get your solutions, what you'll notice is there's only one factor of x. This right here is just a constant. There's no x there, so we don't get an answer there. We have x minus 5, and we have the same x minus 5. I don't need to write it twice. I just need to figure out what makes x minus 5 equal to 0. So add 5 to both sides, and I get an answer of 5. So this is one of the few times that you actually only get one answer. You might say, well, isn't 5 an answer twice? It is, but it doesn't need to be written twice. It's the same number. So just telling me that the answer is 5 is enough. The next one, again, not in standard form, so I'm going to add 16x to the other side. It can't combine with anything that's there, so I'm just going to write the 3 terms out. Now that it's in standard form, I want to start factoring. First thing I'm going to check is for a greatest common factor, and what they do all have in common is they all have an x. A single x is what they all have. So I'm going to write down what's left when I do a takeout. What I have left has 3 terms, so I'm going to try to FOIL factor. This is an easier FOIL factor because it's all positive. Everything is positive. To get 16, it's either going to be 1 times 16, 2 times 8, or 4 times 4. The combination that works here is 4 times 4. So it's another one that has this repeated factor. So you can write it like that, or you can get in the habit of writing it like this. This time, we have a factor here. We can't ignore this x. This x could equal 0 if x equals 0. Really no work on that one. But if you have that x out front, if you put a 0 there, it would make the whole thing 0. And then I need to look at this factor, and again, it's there twice. I don't need to worry about it twice. I just need to know what makes x plus 4 equal to 0. Subtract 4 from both sides, so I get x equals negative 4. So I get this answer and this answer. So this one did have 2 answers. I've got one problem left, and this one is also not in standard form, so I'm going to subtract 1 over here. So I've got x to the 4th plus x to the 3rd minus x minus 1. I'm going to first check for a greatest common factor, and if you look at these 4 terms, they have nothing in common. You might be tempted to think x, but that 4th term does not have an x in it. So I count the terms. There are 4 terms. The only factoring technique that I can try is grouping. So grouping says look at the first 2 terms and figure out what I can take out. I can take out an x cubed, which leaves me with an x plus 1. Then I look at the next 2 terms. I don't really have anything in common, but what you'll notice is the next 2 terms are both negative. So I can take out just a negative 1, and when I divide out a negative, it's going to make it a positive x and a positive 1. Even if you have nothing that you can see as a GCF, you have to at least take out something so you can do the grouping. So if you see negatives, you can take out a negative. If you see positives, you can just take out a positive 1, which essentially won't do anything. We're going to write down my x plus 1 piece, which they both have, and then we're going to write down my x cubed minus 1. What you'll notice is this one's a little more challenging. This is not done yet. This is a perfect cube. This is a difference of perfect cubes. So I get x plus 1. I get, we're going to come off to the side, a is x, b is 1. You have to remember your perfect cube factoring formula. So it starts out as, we still need to start off with x minus 1. So it starts off with a minus b. And then the formula is a squared, which would be x squared, plus a times b, so x times 1 is just x, plus b squared. And b squared is 1 squared, which is just 1. So now we're trying to figure out our solutions. And this one's a little more challenging than what you're going to see on the test. So this is going to be more in the factoring section, but I do want to talk about this with you, kind of lead into where we're headed in this course. We have these 2 factors. I'm going to deal with those first. We have to figure out what makes x plus 1 equal to 0. And if you subtract 1 from both sides, you get negative 1. We're also going to figure out what makes x minus 1 equal to 0. And if we add 1 to both sides, we get x equals 1. So we get positive 1 and negative 1. This piece right here, we're just going to kind of put that on hold. We are not going to be working with that, and that is the case anytime you're dealing with a trinomial that will not factor further. And in this case, this is not going to factor further. We've talked about that when we did the perfect cube factoring. That will never go further. So we are not going to have any answers that result from that. So right now, the only answers that I expect that you write is that x could be 1 or negative 1. And if you want, you can write it as x equals plus or minus 1. So this shows you a wide variety of solving and factoring. Follow those steps every time. Put it in standard form, check to see if you can take out a greatest common factor, factor whatever is left, and then set each factor equal to 0.